For my science fair project, I made 3 microbial fuel cells. Each one is made up of 2 containers like this, which are then attached using a salt bridge, so that it ends up looking like this, with 2 chambers and a salt bridge in the middle. Each one has an electrode inside. Each electrode is made up of a wire glued to carbon cloth with an electrically conductive glue. This is carbon cloth. It is electrically conductive cloth woven from carbon fiber threads. This is what I used for the bottom of my electrodes. In the end, it looks like this. The anode will be filled with mud, and the cathode will be filled with salt water, and they will be connected by a salt bridge in the middle. In the end, it looks like this. The water in the cathode must be salt water, so that the electrons that pass through the electrode can join with the protons that come through the salt bridge. Here's the aquarium pump providing air to the cathode. This means that when the protons and electrons arrive at the cathode, they will join with oxygen in the air to make water. This is what the salt bridge looks like on the inside. If you look on top of the microbial fuel cell, you'll see this. This is a check valve. Since the microbial fuel cell generates carbon dioxide as part of its waste, you need a check valve to keep things from going in while the carbon dioxide can get out. The anode is filled with mud, while the cathode is filled with salt water. The anode is the positive side of the circuit, and the cathode is the negative side. I made 3 microbial fuel cells in total. 1 for the river mud, 1 for the garden mud, and 1 for the hiking trail mud. The 3 types of mud that I tested. Microbial fuel cells generate electricity by using decomposition. When bacteria decompose something, like when a tree falls and it starts to rot, the bacteria generate heat, electrons, protons, and carbon dioxide. So, microbial fuel cells harness electrons and move them through a circuit from the anode chamber to the cathode chamber. The anode chamber contains mud, and the cathode chamber contains salt water. The protons pass through a proton exchange membrane and over to the cathode. And at the same time, an aquarium pump circulates air, which contains oxygen, O2, throughout the cathode. So that's when the electrons that come through the circuits and the protons arrive at the cathode, they join to make hydrogen. And then the hydrogen joins with the oxygen that's coming through to make water. Since microbial fuel cells generate carbon dioxide as part of their waste, you need a check valve to keep things from going in while the carbon dioxide can get out. Power generated by my microbial fuel cell was 0.171 microwatts for the river mud, 0.062 microwatts for the trail mud, and 0.140 microwatts for the garden mud. Power was calculated using the following equation. By Ohm's law, we have the following equation. Voltage is equal to current times resistance. And the power in watts can be expressed as power is equal to voltage times current. We can rewrite equation 1 as Current is equal to voltage divided by resistance. That would make equation 2. Power is equal to voltage squared over resistance. An example is that if the voltage was 5, then we would square the voltage to get 25 and divide by 100 to get 0.25 watts. This was my power. I calculated using this method. What's the difference between power in watts and energy in kilowatts hour? This bulb is rated as 100 watts. That means it has a power of 100 watts. Energy is defined as power times time. So how much energy does this bulb consume? It depends. If it is left on for 1 hour, then the energy consumed will be energy is equal to power times time. So the energy, 0.1 kilowatts, times 1 hour would equal 0.1 kilowatt hour. Remember that the power generated by my fuel cell was. Thus, the energy generated in 1 hour was of, for the river mud, 0.171 microwatt hours. For the trail mud, 0.062 microwatt hour. And for the garden mud, 0.140 microwatt hour. Right now I'm doing another test with oxygen in the cells of my Microbial fuel cell. It's connected to a 4700 ohm resistor.